Hello friends, in this video we will learn how to implement partition function in quicksort. In the previous video we have learned about quicksort and how it is performed on an array to get it sorted. We learned that there are three major steps in quicksort algorithm. First is to choose a pivot element, which can be any element, and then call the partition function, which will bring the pivot element to its sorted position, and all elements which are lesser than pivot will be before the pivot element, and all the elements which are greater than the pivot will be after the pivot in the array. And then we will repeat the process for all the partitions. In this video, we will learn how to implement partition function of quicksort. So let us develop the code using this example array. So we have this array of size 5. So to get it partitioned, we have to pass the array, its start and its end to the partition function. Now declare the variable p_index and initialize it to start. And let us choose the pivot element as the last element of the array. So int pivot equal to arr of end. Also declare I, and it should be initialized to start of the array. But we will do that later. Now we have to compare ith element with pivot. And if ith element is lesser than pivot, then swap arr of I and arr of p_index and increment p_index. And here it is. But since both are pointing to same location, no changes will occur. Now we have to increment p_index. So write p_index++. Next, I should be incremented and the same process should be repeated till we reach the end of the array. So we can put this code inside a for loop. For I equal to start, I less than end, I++. So this will continue till we reach the end of the array. And when this loop is exhausted, we will have the sorted position of pivot pointed by p_index. So we can swap arr of end and arr of p_index. Now we can return the position of pivot, that is p_index, to the calling function. So the return type of function should be integer. So this is how the partition function of quicksort can be implemented.